If you work with AI, you know the last few years have been all about one thing: becoming a better prompt engineer. But what if I told you that entire skill is, well, it's on its way out? Today, we're going to dive into a massive shift in how we build with AI, moving from just talking to models to literally architecting their entire reality. It sounds completely backward, doesn't it? I mean, we've been in this arms race for bigger and bigger context windows, millions of tokens. But the central paradox we're looking at today is that just dumping more data into an AI can actually make it dumber, slower, and way less reliable. This is the core problem that's forcing a complete reinvention of AI engineering. Okay, let's unpack this with a metaphor that we're going to use for this whole explainer. Think of a large language model as a brilliant but kind of naive intern. For the longest time, prompt engineering has been like trying to write the perfect sticky note for that intern. But contextual engineering? That's a whole different ballgame. It's like being their chief of staff. You're managing their inbox, organizing their files, and making dead certain they only see the right info at exactly the right time. We're moving from a simple art form to a full-blown engineering discipline. So what actually happens when we give our intern a bigger desk, that giant context window, and then just bury them under a mountain of paperwork? Well, we run smack into what I like to call the messy desk problem, where more information actually leads to way less performance. And the technical term for this is just fantastic: context rot. It's perfect, right? Just like a person, an AI's performance tanks when its workspace is a total mess. The more irrelevant information, or noise, you throw at it, the harder it is for the model to find the signal. You know, the one crucial piece of information it actually needs to do its job. So get this. Research actually shows our intern suffers from a lost-in-the-middle problem. They really only pay attention to the stuff at the very top and very bottom of the paper stack, just like you would skimming a long report. They get distracted by useless junk, and, this is the big one, forcing them to read every single page is incredibly slow and super expensive. The intern has a finite attention budget, and we're just burning through it on noise. Okay, so if giving the intern more data is a dead end, what's the answer? Well, we don't need a new intern. We need a new role for ourselves. We need to become the chief of staff, the manager of their entire information flow. And this right here, this is our new job description. Contextual engineering isn't about writing a perfect sticky note anymore. It's about designing the intern's entire information ecosystem. Our job is to curate, compress, and isolate information to squeeze the absolute most value out of every single thing they read. So how do we actually do this? Let's get practical. Let's open up the toolkit of a context architect. And the very first job is the most basic one: just keeping the intern's immediate workspace clean and focused. The first tool is just-in-time retrieval. Instead of dropping the entire company library on the intern's desk, you just give them a library card. So the AI first sees a map, like a list of file names. It then decides for itself which specific document it needs for the task, and a tool fetches only that document, just in the nick of time. This keeps its desk totally clean. The next tool in the box is context compaction. Think of this as the end-of-day cleanup. As the conversation with the AI gets longer, its context window fills up with junk, like raw data from a calculator tool or a web search. We call this tool debris. This process is like having the intern summarize their findings in a nice, clean memo and then just throw away all their rough scrap paper. And there are a bunch of different ways to do this tidying up. We can automatically pull out filler words, we can compress text into these super efficient data formats, or we can just filter out the raw outputs after the AI has gotten the key insight. The point is, there's a whole suite of engineering tools emerging just for this job. Okay, so we've tidied the intern's desk. Great. Now let's build them a better office. We need to stop them from getting distracted by their coworkers by building them quiet rooms for focused work. The problem here has another great name: context poisoning. Imagine you ask your AI agent to first write a beautiful creative poem, and then, in the very next step, to analyze a dense legal contract. If both of those tasks happen in the same context, that creative, metaphorical language from the poem can actually bleed into the legal analysis, leading to, disastrous results. That's context poisoning. And the solution is this brilliant architectural pattern called supervisor worker. A main supervisor AI manages the overall goal. But when it needs a specialized task done, like data analysis, it spins up a worker AI in its own completely separate, quiet room with a totally fresh, clean context. The worker does its job, sends only the final answer back, and the supervisor's main context stays absolutely pristine. So our intern has a clean desk and a quiet office. What's next? Well, they need a long-term memory system. And I don't mean just a pile of documents. I mean a truly intelligent filing cabinet. For a while, our AI's memory has been Retrieval Augmented Generation, or RAG, which, let's be honest, is basically a fancy keyword search. But the new frontier is Graph RAG. This doesn't just store documents, it builds a whole knowledge graph of how all the ideas inside those documents are connected. So you go from asking, what does this document say, to asking, how do all these different concepts relate to each other? It's a massive leap. And this brings us to the absolute cutting edge, agentic memory, or AMEM. This is a system that's literally designed to mimic the human brain. It doesn't just store information, it actively builds connections. It refines its old memories when it learns something new, and it evolves its own understanding of the world over time. And this is how it works. It's brilliant. AMEM turns every new fact into a little atomic note. It then automatically links that new note to all the related old notes in its memory. It even finds contradictions and updates its own knowledge. So when the AI goes to retrieve a memory, it gets back a whole web of connected ideas, not just a single isolated fact. Okay, so let's just pull back for a second. We've gone from tidying a desk to organizing an office to building a brain. So what does this all mean for the future? Well, we're no longer just giving instructions. We're becoming architects of the AI's entire cognitive environment. And this leads to a pretty stark conclusion. Manually writing long, complex prompts is dead. It's the new assembly language. It's a low-level, brittle, and frankly inefficient way of working that is quickly being replaced by programmatic, high-level tools. And the ultimate tool for the context architect is a framework like DSPy. With this, you stop writing prompts completely. Instead, you write code that just defines the task, and an optimizer runs in the background, testing hundreds of options to learn the most effective way to talk to the AI. You're not the prompter anymore. You're programming the prompter. Which brings us to the single most important takeaway from this entire explainer, a quote that's been making the rounds everywhere lately. Do not be a prompt writer, be a context architect. This is the job. This is the future of building with AI. And that leaves us with one final provocative question to think about. If our role as chief of staff is increasingly being automated by frameworks like DSP, and the AI's memory evolves all by itself with systems like AIM, what's left for the human? What does our role become? Are we the architects, the goal setters, the ethicists? That's the big question we'll all need to answer next.